The solar system is a vast and fascinating place, filled with a variety of celestial bodies that orbit around the Sun. In this chapter, we will explore the components of the solar system, including the planets, their moons, and small bodies such as asteroids and comets. By studying these objects, scientists have been able to uncover many secrets about the formation and evolution of our cosmic neighborhood. At the center of the solar system is the Sun, a massive star that provides light and heat to all the planets. The Sun's gravitational pull keeps the planets in their orbits, creating a delicate balance that has existed for billions of years. The 8 planets in our solar system are divided into 2 groups: the inner rocky planets, Mercury, Venus, Earth, and Mars, and the outer gas giants, Jupiter, Saturn, Uranus, and Neptune. Each planet has its own unique characteristics, from the scorching temperatures of Venus to the icy surface of Neptune. In addition to the planets, the solar system is home to a multitude of moons that orbit around these worlds. Some moons, like Earth's moon, are large and have complex geology, while others are small and irregularly shaped. Moons play a crucial role in the dynamics of their parent planets, influencing tides, weather patterns, and even the possibility of life. For example, Jupiter's moon Europa is believed to have a subsurface ocean that could harbor life. Beyond the planets and their moons, the solar system also contains a vast number of small bodies that orbit the Sun. Asteroids are rocky remnants from the early solar system, while comets are icy bodies that originate from the outer regions. Studying these small bodies can provide valuable insights into the history of the solar system, including the conditions that existed when the planets were forming. One of the most exciting aspects of studying the solar system is the constant stream of new discoveries that are being made. Thanks to advances in technology, such as powerful telescopes and spacecraft missions, scientists are able to explore distant worlds like never before. Recent missions to Mars have revealed evidence of ancient water flows, while the New Horizons spacecraft provided stunning images of Pluto and its moons. These discoveries are reshaping our understanding of the solar system and challenging long-held theories about how it formed. In this chapter, we will delve into the mysteries of the solar system and its components, from the innermost planet to the farthest reaches of the Kuiper Belt. By examining the geology, atmospheres, and magnetic fields of these celestial bodies, we can gain a deeper appreciation for the beauty and complexity of our cosmic home. Join us on a journey through the solar system and discover the secrets that lie hidden among the stars. Recent discoveries about planets have revolutionized our understanding of the solar system. One of the most exciting findings is the detection of exoplanets, planets that orbit stars outside our solar system. Thanks to advancements in technology, astronomers have identified thousands of exoplanets, some of which may have the potential to support life. These discoveries have opened up a whole new realm of possibilities for planetary exploration. In our own solar system, there have been several significant discoveries as well. For example, the dwarf planet Pluto was reclassified as a dwarf planet in 2006, changing our perception of the outer solar system. Additionally, the New Horizons mission provided detailed images of Pluto and its moons, shedding light on this distant world. Another major discovery is the presence of water on Mars. Evidence of ancient river valleys and lake beds suggests that Mars may have once had a much wetter climate. This has fueled speculation about the possibility of past life on the red planet. Jupiter, the largest planet in our solar system, continues to surprise scientists with its dynamic atmosphere. The Juno mission has revealed stunning images of Jupiter's polar regions and provided new insights into its complex weather patterns. Saturn, known for its beautiful rings, has also been the focus of recent discoveries. The Cassini spacecraft discovered plumes of water vapor erupting from the moon Enceladus, indicating the presence of a subsurface ocean. This finding has raised questions about the potential for life in the outer solar system. Uranus and Neptune, the ice giants of the solar system, have also been the subject of new discoveries. Observations from Earth-based telescopes and the Voyager 2 spacecraft have revealed details about their atmospheres and unique magnetic fields. These findings have deepened our understanding of these distant worlds. The study of exoplanets, planets beyond our solar system, has provided valuable insights into the diversity of planetary systems in the universe. Scientists have discovered a wide range of exoplanets, from hot Jupiters close to their stars to rocky planets in the habitable zone. These discoveries have challenged our assumptions about how planets form and evolve. Overall, recent discoveries about planets have expanded our knowledge of the solar system and beyond. From exoplanets to the outer reaches of our own solar system, each new finding brings us closer to unlocking the secrets of the universe. Moons have long been a subject of fascination and intrigue for scientists and space enthusiasts alike. These celestial bodies, which orbit planets within our solar system, have proven to be not just interesting objects to study, but also key players in the dynamics of their respective planetary systems. In this chapter, we will delve into the exploration of moons and their significance, shedding light on the valuable insights they provide into the mysteries of the universe. The exploration of moons began in earnest with the advent of space exploration missions in the mid-20th century. The first successful flyby of a moon was achieved by NASA's Pioneer 4 spacecraft in 1959, which passed by the moon and provided valuable data on its composition and surface features. Since then, numerous missions have been launched to study the moons of various planets, including the iconic Voyager and Galileo missions that provided unprecedented views of the moons of Jupiter and Saturn. One of the key reasons why moons are of such interest to scientists is their potential to harbor life. While the search for extraterrestrial life has largely focused on planets, moons have emerged as promising candidates in recent years. Moons such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are believed to have subsurface oceans that could potentially support microbial life. By studying the composition and geology of these moons, scientists hope to uncover clues about the possibility of life beyond Earth. Furthermore, moons play a crucial role in shaping the environments of their parent planets. For example, the moon's gravitational pull on Earth is responsible for the tides, which in turn influence the behavior of marine life and coastal ecosystems. Similarly, the moons of gas giants like Jupiter and Saturn contribute to the complex interactions within their planetary systems, influencing everything from the formation of rings to the stability of orbits. By studying the moons of different planets, scientists can gain a better understanding of the processes that govern the evolution of planetary systems. In addition to their scientific significance, moons also hold cultural and historical importance. Many moons in our solar system are named after figures from mythology, such as Jupiter's moons Io, Europa, Ganymede, and Callisto, which are named after lovers of the god Zeus. These names serve as a reminder of the enduring influence of ancient myths on our understanding of the cosmos. Furthermore, the study of moons has inspired countless works of art, literature, and music, reflecting the universal fascination with these enigmatic worlds. As we continue to explore the moons of our solar system, new discoveries are constantly reshaping our understanding of these intriguing bodies. From the icy geysers of Enceladus to the towering mountains of Miranda, each moon offers a unique window into the diversity and complexity of our celestial neighborhood. By unraveling the secrets of moons, we not only gain insights into the origins and evolution of our solar system, but also deepen our appreciation for the wonders of the cosmos. The exploration of moons is a testament to the human spirit of curiosity and exploration, driving us to push the boundaries of knowledge and venture into the unknown depths of space. Small bodies in the solar system play a crucial role in understanding the formation and evolution of our cosmic neighborhood. These bodies, which include asteroids, comets, meteoroids, and dwarf planets, provide valuable insights into the early stages of the solar system and its ongoing dynamics. In this discussion, we will explore the characteristics, origins, and significance of these small bodies. Asteroids are rocky remnants from the formation of the solar system, primarily located in the asteroid belt between Mars and Jupiter. They vary in size from a few meters to hundreds of kilometers across. Some asteroids have even been visited by spacecraft, such as the Hayabusa mission to asteroid Itokawa and the OSIRIS-REx mission to asteroid Bennu. Comets, on the other hand, are icy bodies that originate from the outer regions of the solar system. When a comet approaches the sun, it heats up and releases gas and dust, forming a glowing coma and a tail that points away from the sun. The study of comets provides valuable information about the composition of the early solar system and the delivery of water and organic molecules to Earth. Meteoroids are smaller fragments of asteroids and comets that enter Earth's atmosphere and burn up, creating bright streaks of light known as meteors or shooting stars. Some meteoroids survive the journey through the atmosphere and land on Earth's surface as meteorites, which can be studied to learn more about the composition of the solar system. Dwarf planets are a category of small bodies that share characteristics with both planets and asteroids. Pluto, once considered the ninth planet, was reclassified as a dwarf planet in 2006 due to its small size and location in the Kuiper Belt. Other dwarf planets in the solar system include Eris, Haumea, and Makemake. These small bodies offer a wealth of information about the formation and evolution of the solar system. By studying their compositions, orbits, and interactions with other objects, scientists can piece together the history of our cosmic neighborhood. Small bodies also pose potential hazards to Earth, as evidenced by the impact of the Chicxulub asteroid that led to the extinction of the dinosaurs. Understanding the properties and trajectories of small bodies is essential for developing strategies to mitigate the risk of future impacts. In conclusion, small bodies in the solar system are fascinating objects that hold the key to unlocking the mysteries of our cosmic origins. By studying asteroids, comets, meteoroids, and dwarf planets, scientists can gain valuable insights into the history and dynamics of the solar system, as well as potential threats to our planet. Continued exploration and research of these small bodies will undoubtedly lead to new discoveries and a deeper understanding of our place in the universe. The new findings in our understanding of the universe have profound implications that challenge our current knowledge and theories. These discoveries have the potential to revolutionize the way we view the cosmos and our place within it. One of the most significant implications is the discovery of exoplanets, planets that orbit stars outside our solar system. This discovery has expanded our understanding of planetary systems and raised questions about the possibility of life beyond Earth. The study of exoplanets has also provided valuable insights into the formation and evolution of planetary systems, shedding light on the diversity of worlds that exist in the universe. Another important implication of new findings is the discovery of dark matter and dark energy. These mysterious substances make up the majority of the universe's mass and energy, yet their nature remains largely unknown. Understanding dark matter and dark energy is crucial for unraveling the mysteries of the universe, such as the accelerated expansion of the cosmos. The discovery of gravitational waves is another groundbreaking finding that has opened up new avenues for studying the universe. Gravitational waves are ripples in space-time caused by the motion of massive objects, such as merging black holes or neutron stars. By detecting these waves, scientists can observe events that were previously invisible, providing a new way to study the universe. The study of black holes has also seen significant advancements in recent years, with the first-ever image of a black hole captured in 2019. This image confirmed the existence of these enigmatic objects and provided valuable insights into their properties and behavior. The discovery of interstellar objects, such as Oumuamua and Borisov, has challenged our understanding of the origins of celestial bodies in our solar system. These objects originate from outside our solar system and offer a glimpse into the diversity of objects that populate interstellar space. The study of small bodies, such as asteroids and comets, has also revealed new insights into the early solar system and the processes that shaped it. By studying these objects, scientists can learn more about the conditions that existed during the formation of the solar system and the role that small bodies played in its evolution. Overall, the new findings on our understanding of the universe have far-reaching implications that will continue to shape our knowledge and perception of the cosmos. These discoveries challenge our existing theories and open up new possibilities for exploration and discovery. As we continue to uncover the secrets of the universe, we are sure to encounter even more surprises and revelations that will expand our understanding of the cosmos. In conclusion, the exploration of our solar system has provided us with a wealth of new discoveries about planets, their moons, and small bodies. From the icy geysers of Enceladus to the mysterious dark spots on Neptune, each new finding has deepened our understanding of the complex interactions that shape our celestial neighborhood. But our work is far from over. There is still so much left to uncover, so many questions left unanswered. As scientists, it is our duty to continue pushing the boundaries of knowledge, to keep exploring, keep discovering, keep learning. The mysteries of the solar system are vast and varied, and it is up to us to unlock their secrets. So I urge you, my fellow researchers, to join me in this quest for knowledge. Let us embark on new missions, conduct new experiments, and analyze new data. Together, we can unravel the remaining mysteries of the solar system and pave the way for future generations to build upon our discoveries. The journey ahead will be challenging, but the rewards will be immeasurable. So let us not rest on our laurels, but instead let us push forward with determination and curiosity. The solar system awaits our exploration, and it is up to us to rise to the challenge. Thank you.